We are preparing to celebrate the 75th anniversary of a great genocide in August 2024. I don't know if destruction can be destroyed by destruction. However, an excellent film about Oppenheimer, who is considered the father of this destruction, was released as the first step of this celebration. The worst decade in world history, that is 1940s, began. Italy and Japan joined the war of aggression started by Germany. Against these invasions, England, America and Russia forgot their old differences and stood together on the side of the Allies. In the beginning, the invaders were always strong. Trying to achieve victory through destruction, they were very interested in using modern science for more destruction. At that time, the attention of all parties had been focused on using the discoveries made for science to destroy. Here, they researched the production of a bomb that could release enormous destructive energy by changing the function of an atom, which is considered the smallest unit of any substance. In general, what happens in a bomb is that several explosive chemicals are mixed together and allowed to react. When the existing compounds break down and become new compounds, the chemical energy that was bound in them is released. We see that energy as an explosion. But the functioning of atomic bombs or nuclear bombs is different. It is not the bond energy between the atoms of a compound that is released. The binding energy between protons and neutrons in the nucleus of an atom. The nuclear energy stored in a mass is much greater than the chemical energy stored in it. Therefore, an atomic bomb is more destructive than an ordinary bomb. Before telling more details about it, we need to explain what this atom means. Every element in this world is made up of tiny particles that are invisible to the eye. This smallest particle is called atom. Animals, leaves, and even the air we breathe are made of atoms. We cannot see an atom with the naked eye, because they are very small. The word atom is derived from the Greek word atomos, which means indivisible. The central part of this small atom is called the atomic nucleus. It is very small compared to the atom. For example, if an atom is the size of a football field, the nucleus can be compared to a football in the middle of the field. This nucleus is made up of even smaller particles called protons and neutrons. There is a large empty space around it. There are electrons moving throughout this space. Just like the planets move around the sun, it's like that. The number of electrons in an atom is equal to the number of protons in the nucleus. Likewise, electrons are negatively charged and protons are positively charged. The positively charged protons in the nucleus try to pull the electrons spinning in the space around them to the nucleus, but due to the negative charge of the electrons, they do not fall on the nucleus. Likewise, neutrons in the nucleus are a kind of neutral particles by nature. Thus, due to the equal energy between electrons and protons, that atom remains neutral. But breaking this balance of power can bring out the enormous strength within it. We call it nuclear fission. But it is difficult to extract this nuclear energy from every element. Because I explained that the nucleus of an atom is usually very stable. But there are some atoms whose nucleus is not so stable. They easily break their balance and release energy, and spontaneously transform into other stable atoms. These are called radioactive elements. Although there are many radioactive elements, plutonium and uranium are the two elements that are most efficiently used to make bombs. This is uranium. When they are raw like this, they don't look so dangerous. But uranium has a lot of energy. In the production of an atomic bomb, the uranium nucleus is struck by a neutron. Then the protons and neutrons in the uranium nucleus are separated and two different atoms called krypton and barium are formed. Similarly, 3 more neutrons are formed here. Those 3 neutrons collide again with 3 uranium nuclei and become 9 neutrons. This happens again and again within an unimaginably short period of time. This is like spreading a dangerous virus. We call a process like this a chain process. Through this chain process, the enormous energy contained in uranium is simultaneously released. There is a lot of heat and radiation coming out. In a nuclear power plant, water is heated and turned into water vapor by the high heat released. The steam turns the turbine and produces electricity. Here, these radiations cannot be exposed to the external environment at all. It is extremely destructive. For this reason, a nuclear power plant has a specially prepared chamber for the aforementioned nuclear reaction to take place. This is called a nuclear reactor. There are methods to limit and control the activity of neutrons in a nuclear reactor. But in a nuclear bomb, the high energy of these radioactive materials is made to explode freely in the environment without control. This high heat and radiation comes out there. Then it is extremely destructive. Although this is simply said, this is an extremely complicated matter. If the entire mass of uranium required for an atomic bomb is stored in one chamber, it can explode the moment it is made. The other thing is to accurately calculate the amount of destruction here. Likewise, care should be taken not to let this nuclear knowledge fall into the hands of the opposite party. Due to many such issues, the United States is very cautious in the extremely complicated task of developing an atomic bomb. The program to develop nuclear bombs was launched under the Manhattan Project. The main laboratory complex was established in 1942 in Los Alamos, New Mexico. This is a laboratory complex operated under very strict security. There were strict security measures in place. Scientists in each department were even restricted from discussing with each other. The director of the scientific department of the Manhattan Project was the physicist J. Robert Oppenheimer. He is the most special person in this role, and I hope to make a separate video about Oppenheimer next week.
To make significant decisions.
Research activities are extremely successful. The world's first atomic bomb test, codenamed Trinity, was conducted. It was on July 16, 1945 in a deserted desert in New Mexico, United States. But by that time the Soviet forces had already defeated Nazi Germany. After the surrender of Germany on May 8, 1945, the Allies turned their attention to the Pacific Front. At that time, 2 atomic bombs named Fat Man and Little Boy had been produced by the Manhattan Project. America had a strong need to respond to the massive attack on Pearl Harbor by the Japanese. On July 26, 1945, the Allies were told to surrender unconditionally to the Royal Japanese Armed Forces, or else the alternative would be swift and total annihilation. But the Japanese government rejected this ultimatum. On August 6 and 9, 1945, the United States dropped atomic bombs on the Japanese cities of Hiroshima and Nagasaki, respectively. This was the first and only time nuclear weapons were used in an armed conflict. Due to the intense heat that came out, people, animals, plants, buildings, etc. all got burnt in an instant. Both bombs killed approximately 2 million people simultaneously. Most of them are civilians. After that, for many months, people were dying from burns, radiation and injuries, other diseases and malnutrition. On August 15, 1945, Emperor Hirohito announced Japan's surrender. Thus ends the most brutal and deadliest war in human history. Celebrating the victory over Japan, the people erupted in joy. The end of the war is indeed a matter of rejoicing. Many people who talk about the dropping of the atomic bombs on Hiroshima and Nagasaki say that the dropping of the atomic bombs was necessary to end the war. But can we forget? Common people and women were mostly killed in this attack. Big and small children. Even after that, children who were not born at that time became disabled.